RK here. Let's kick off today's show with a quiz.
No, man, it's easy. Name the biggest environmental problem in the news today.
I always hear about ozone depletion and global warming.
Yeah, me too. You know, a lot of people think they're two names for the same problem.
Survey says...
Today, let's talk about global warming, and another time we'll tackle ozone depletion.
Dude, if the planet got warmer, I could surf all year.
Well, you know, there are actually good points about global warming. Yep, that's right. I said it. Not all global warming is bad.
And when you say bad, you mean bad for us human beings.
True, but that's another story. Now, as I was saying, not all global warming is bad. In fact, without it, we humans would have a pretty tough time living on this planet.
Friend, that is sacrilege, plain and simple. You are going straight to hell for that one.
No, really, not all global warming is bad. Here's why. All energy on the Earth ultimately comes from the sun. We'll talk about that more in our solar energy show. But for instance, solar panels can directly convert the sun's energy into electricity. Plants store the energy from the sun in the form of sugar in their leaves.
Sweet.
So, the sun shines down on the Earth and it gets hot.
Thanks.
The Earth then takes this heat, plus the heat from fires, volcanoes, lightning, the heat from all natural and human activity, and radiates it back out into space. The final frontier. In fact, the Earth radiates about twice as much heat as it absorbs from the sun. Now, 84% of that heat given off is blocked from going back out into space by the Earth's atmosphere, which sends it back down at us.
Yo, right back at you, man.
This re-radiation by the atmosphere is what's called the greenhouse effect. And if that didn't happen, the temperature on the planet would be 33 degrees Celsius or 59 degrees Fahrenheit colder. That means that summers in Disney World might only get up to 1 degree above freezing, and winters, they might not even hit 19 below.
Well, golly!
Oh, wait just a cotton-picking minute. Are we supposed to believe there's some sort of being floating around over our heads that can catch and throw heat?
Not exactly. The Earth's atmosphere is made up of 0.03% CO2, and when CO2 gets hot, something interesting happens.
Yeah, your soda gets flat, dude.
We'll talk about that in our acid rain episode. No, when carbon dioxide or CO2 gets hot, the bonds between the atoms start to vibrate. Now, molecules don't exactly get tired, but if and when they stop vibrating, they give off the heat that started them vibrating in the first place. This heat that we're talking about, and heat is a form of energy, is known as infrared or IR radiation. It's the same radiation that's used to keep food warm at fast food restaurants. You want fries with your radiation? And this IR light has even less energy than the visible light that our eyes see.
So, how do I get my awesome tan with such low energy?
Actually, it's UV or ultraviolet light that gives us a tan, as well as skin cancer. And UV has more energy than either IR or visible light. UV breaks bonds, whereas IR just vibrates bonds. But we'll talk about that more in the ozone episode.
I can't wait, dude!
So, where does the CO2 come from? No, it does not come from space. But actually, there are a variety of man-made as well as natural sources of CO2. 110 billion metric tons of CO2 are used by plants in photosynthesis each year. Another 93 billion metric tons is stored by the Earth's natural processes in oceans by coral and seashells, and in other areas by minerals like limestone. 90 billion metric tons are given into the atmosphere by natural processes. 55 billion metric tons of CO2 are emitted into the atmosphere by human and other animal respiration, and another 55 billion metric tons by plant and animal decay. 2 billion metric tons are due to deforestation, some of which is naturally occurring, and some of which is due to the actions of humans. Finally, 5 billion metric tons are emitted due to the burning of fossil fuels.
If you do the math, or better yet, let me do it, you'll see that the atmosphere is getting 3 billion metric tons of carbon dioxide each year. That's right.
That comes out to about a 1.5 ppm increase annually. That's 1.5 molecules of CO2 for every 1 million molecules of anything in the air each year.
I don't think I have a measuring spoon for 1.5 molecules.
It's just an average.
Okay, So we got a little carbon dioxide in our soda and a little in our air, but what in the Sam Hill does that have to do with global warming?
Well, if you look at the amount of carbon dioxide in the atmosphere, and you also look at the difference between the average temperature from 1950 to 1980 and the temperature every other year, an interesting pattern develops. Each time the amount of carbon dioxide in the atmosphere increased, there was an increase in the average global temperature.
How in the heck do you measure how much soda bubble was in the air 160,000 years ago?
It's a good question. And you know, there's a really neat answer. Scientists have been able to find air bubbles trapped in ice. And using carbon and deuterium dating, which we will talk about another time, they're able to tell how old the bubble is. Then they just measure how much CO2 is in the bubble the same way that they would today, using a gas chromatograph mass spectrometer, which is really good at detecting very small amounts of things.
How small, dude?
Well, dude, have you ever heard of the saying, it's like finding a needle in a haystack? Well, if we pretend that a molecule is a needle, a typical modern GCMS can find one particular needle in 1 million stacks of 1 million other needles.
Can it find my left sock?
Let's look at the global temperature over a smaller range of years, say the Industrial Revolution in the late 1800s through today. Since 1860, the CO2 content of the atmosphere has risen 20%. And, as you can see, the average global temperature has increased almost 1 degree.
You mean to tell me all this hoopla's over 1 little degree?
Heck, I ain't even got a degree.
Well, that 1 degree is important, but that does bring up an interesting point about graphing and statistics. Let's take another little quiz. Which one of these two graphs shows a larger temperature change?
Like I said, I ain't got no degree, but that one right there on the right looks a lot scarier.
Actually, the two graphs are the same. All I did was to make the numbers on the y-axis, the left side, bigger. That makes the numbers look closer together. It's a trick people sometimes play to make their numbers seem more or less important, so be on the lookout for that.
Well, thanks. I will. It just don't seem right for folks on the news to trick us like that.
I couldn't agree more. So, even if the atmosphere gains only a little CO2 each year, it only takes a little more CO2 to cause a little temperature change. And a little temperature change can make big changes in the weather.
It ain't nice to mess with Mother Nature.
People respirate and plants photosynthesize. Plants give off oxygen and use CO2. We give off CO2 and use oxygen. It's a great system that results in a relatively constant amount of CO2 in the atmosphere. In nature, balance is very important.
In surfing, balance is very important.
Before the Industrial Revolution, CO2 levels did change due to a variety of reasons like volcanic eruptions, and, the weather did change too.
But I thought CO2 was good for plants, and then they'd grow faster, and they'd cancel our effect out.
Well, the statistics don't seem to support that since CO2 levels are increasing. But that could be the result of us cutting down trees, like in the rainforest. There's a lot of interdependent things going on that make it really difficult to tell what's happening.
Yeah, the meteorologist on the news never gets the weather right.
For instance, an increase in the temperature of the ocean decreases the solubility of CO2 in the ocean, which increases the amount of CO2 in the atmosphere, which leads to an increase in global temperature. But that same increase in ocean temperature increases phytoplankton growth, which increases the CO2 absorption by the ocean, which decreases the amount of CO2 in the atmosphere and decreases global temperature. However, the same ocean temperature increase decreases ocean circulation, which decreases the growth of phytoplankton, which decreases CO2 absorption by the ocean, which increases CO2 in the atmosphere and increases global temperature. Plus, that same increase in ocean temperature increases the ice melting, which decreases the amount of light reflected by the Earth, which increases global temperature. But an increase in global temperature makes the tree line move north, which increases CO2 absorption from the atmosphere, decreasing the amount of CO2 in the atmosphere and decreasing global temperature. Also, an increase in global temperature increases water evaporation, and low clouds lead to high humidity, which leads to increased global temperature. But high clouds reflect light and lead to a decrease in global temperature.
What are we going to do about it?
Well, let's have a look at which countries emit the most CO2.
I'm skeptical about them figures. Just like you told me to be.
Very good. This graph actually lists emissions per person. Now, the US emits a lot per person and is in fact number one in total emissions. But China, with so many more people than any other country on Earth, is actually number 3 behind the former Soviet Union. Plus, China is in the process of building more coal-burning power plants, which emit a lot of CO2, while most other developed countries are phasing them out. So, China is climbing to the top of both lists.
What are we going to do about it?
Well, we can just keep studying the problem and do nothing, which some might say is like sticking our heads in the sand.
Sand.
We could try to prepare for the effects.
Which is great, my friends, if you're making a Hollywood movie. Otherwise, it's as potent as a fart in a windstorm.
Or we could take action to prevent adding more CO2 to the environment. Because if our little extra amount of CO2 is what's causing an increase in global temperature, don't we have a responsibility to the planet and to our children to do something about it?
But ain't there other greenhouse gases?
Yes, in fact. Although a mathematician and scientist named Fourier first discovered the greenhouse effect, it was another scientist named Tyndall who showed that it was primarily due to CO2 and the most common chemical on Earth.
Survey says water!
We also know that methane is great at absorbing and emitting IR radiation.
Ain't methane what comes out the southbound end of a northbound cow?
That's right. In the atmosphere, methane, and water as well, are almost 100% due to natural sources. Although, factory farming is leading to a sharp increase in methane emissions.
More natural sources!
Yes, but remember the balance in nature.
And surfing.
If our actions are upsetting the balance, shouldn't we try and do something about it? In 1900, Arrhenius estimated that doubling CO2 concentrations would increase the average global temperature by 5 or 6 degrees Celsius. However, in the last 100 years, CO2 concentrations have increased 25%, and we've only seen a 1/2 to 0.7 degrees Celsius temperature increase. Current estimates say that doubling CO2 could lead to a 1.5 to 4.5 degrees Celsius temperature rise. However, that could lead to some pretty serious consequences for us and for life on this planet as we know it.
What are we going to do about it?
Well, think about how you live. Do you recycle? Does your lifestyle burn or consume large amounts of fossil fuels? I mean, do you drive when you could walk or ride a bike? Do you take available public transportation? Is your house green? Do you do something as simple as using reusable cloth bags when you grocery shop instead of paper, which depletes the forests, or plastic, which is made from fossil fuels? And yeah, they're recyclable, but they're not recycled very often, and they certainly don't biodegrade when they're not recycled. So that's it for today. You passed the test. See you next time.
Plutonium is not green and does not glow.
This is plutonium.
And this is Professor K, totally being arrested by the Nuclear Regulatory Commission.
Come on, dude, it was just a picture. I'm serious. It wasn't a really sample of plutonium. That'd be too dangerous to have in here. Come on. Check out the Professor K Show website for lots more ways you can help out.